Justin, who's the CTO from Rigado, is going to be up here talking about unlocking Bluetooth's potential and leadership in commercial and IoT markets. Justin is the co-founder and CTO of Rigado. He leads the technology and strategy for Rigado's edge connectivity and computing solutions. He has a background and expertise in low-power wireless technologies, and he's helped grow Rigado from a product design firm to a worldwide leader in connectivity for large-scale commercial IoT products. So please welcome Justin to the stage. His presentation on commercial IoT.
Thanks, Jeff. Good morning, everybody. Today I want to share with you some of the lessons we've learned as we've helped companies enable commercial IoT using BLE. So the first thing to think about is looking at the landscape or the recipe that's used for all of these commercial IoT installations. Typically we see a lot of Bluetooth devices, things that are like room occupancy sensors or lighting and control type devices, or we're looking at tracking employees or guests with their badges or ID cards when they're in a hotel. And we see some sort of cloud infrastructure, something that's going to be analyzing all this data, making actionable reports, maybe sending alerts if something's out of spec, or looking for optimizing the workflow of a conference room. But BLE devices don't speak cloud, and cloud doesn't speak BLE. So in between those two, we need something in the middle. In consumer, this has always been the mobile phone. But in commercial buildings, we can't rely on the Bluetooth phone to be there to bridge this gap. Instead, we use these gateways. And we're seeing this play out in a lot of different use cases. We have things like lighting. We've got location services. There are also all kinds of optimization in terms of sensing different like soap dispensers in bathrooms, make sure janitorial staff can update and reorder the stock. And these are in all kinds of different markets. Retail, hospitality, we see a lot in restaurants. We're seeing a lot in different warehouses and transportation, and especially in areas like healthcare. So how are all these BLE devices supposed to talk to the cloud devices? Well, the first thing that I say is commercial isn't connected. That's a little bit of an oxymoron, but what I mean by connected is we look at the Bluetooth devices that typically connect to our consumer devices like phones. That's usually done with a Bluetooth connection. So we'll have something like a hands-free profile for your Bluetooth headset, or we'll have a streaming audio profile. Human interface, we have mice, things like that. And all these are very interoperable and act in a connected manner in a one-to-one relationship between the phone or the laptop and the Bluetooth device. They take advantage of things like security from those bonded connections, and we can do things like optimize their power using connection intervals, adjust the slave latency so we can skip connections, or use a supervisor timeout for the same thing. But when we talk about a use case like a big box retail store that wants to get a heat map of where the carts are moving around in their store so they can do things like better optimize the layout, if we try to use a connection for that, we're going to be having a lot of problems as that cart moves around. So in commercial IoT, the first thing we've noticed is a lot of companies are ditching those connections and moving more to an advertising type mechanism. And that's great. Advertising where the beacons are, put a beacon on this cart and you can see it move around inside the store. Lots of different gateways can capture the signal levels coming from those advertisements, and then use that to build sort of a location map of where it's been. And this is happening with a lot of companies that we're talking to today. But what happens if we want to take a sensor and put it on that cart so that we can figure out what the weight is of the stuff inside that cart? Now we need to figure out a way to get sensor data along with this advertising data sent to these gateways. Typically what I see companies do when they're faced with this challenge is they dive into the Bluetooth spec and they figure out how advertising works. And they look and they say, okay, I've got 39 bytes in here, but oh wait, no, that gets shut down to 31 bytes because of all this extra headers. And then, okay, there's advertising data like the UUID that I can connect to, so that limits it even more. And they're left with just a few bytes, and they're cramming something in there in a completely proprietary way. When they do that in a proprietary way, it makes it very difficult for us to have interoperability between different devices that are out there, occupancy sensors, carts, etc. Additionally, when those advertising mechanisms are used in this cart example, we've got a lot of situations where an advertisement isn't going to carry the information back and forth that we need. That might be adjusting the threshold of when that sensor is triggered, or looking into setting up a more configuration of the security credentials, keys, things like that. And we live in an era where our cars and our thermostats are getting software updates, so pretty much can guess the shopping cart's going to get a software update at some point. And all of those things are still happening over connections, because that's the way that those devices will string back and forth. Advertisements are only in one direction. But the good news is, as we've probably heard several times this morning already, that Bluetooth mesh is solving a lot of these problems. The models, which are just like the profiles that we've used in the hands-free and the human interface devices like mice, are providing a standard way to get advertising-based data from these sensors and other things that are deployed in commercial buildings, and communicate that to the applications that are using them. So instead of somebody looking at that advertising PDU and trying to figure out, how do I fit sensor data in here? Now we're seeing from the mesh a standardized way to do that. It still uses advertising, it still is bidirectional, and then we also have a lot of great features from being able to extend the range of these networks. Now, just to be clear, the range extension and the mesh and the hopping and the bouncing the network of the messages all around isn't the most exciting part for me. It's that device vendors will now have a consistent and standardized way to build something like an occupancy sensor that as a service companies can use when they're developing software that's going to be interacting with these commercial networks. If we look at the consumer market, pretty much all consumers are already BLE enabled. The market report from Bluetooth says 100% of the platform devices like mobile phones, tablets, and laptops in 2018 are being built with Bluetooth built in. But I don't think there's a similar statistic for commercial buildings. So what's it going to take to get all these buildings connected? Well, I play a little bit more with that retail big box store example. I can imagine several different use cases. We have something like a cart tracking example I said earlier. There are other applications like compliance, where something like an AED needs its batteries checked regularly, or a fire extinguisher needs to make sure that it's been serviced, or emergency lighting's batteries are still operational. And these big box stores want automated ways to solve that, so they don't have to put a person on a ladder with a clipboard to figure out if those things are in compliance. There are displays, like store displays, some little widget that's up front. Somebody wants to pick it up and look at it, interact with it. And these stores want to measure the engagement that their customers have with these different devices. So maybe there's a Bluetooth-enabled accelerometer-based device to capture which devices are getting attention. And there's lots of others. Track the employees, look into their safety, do their metering. And the way this is playing out is that each one of those applications is bringing its own gateway to the party. And that's really expensive, because not only does each of those gateways need to be purchased, somebody has to get on a ladder and install it. Somebody needs to work with the IT departments to configure it onto the network, to make sure it's secure, make sure it's monitored. And then each one of those needs to be supported through its life cycle. And that's holding back commercial IoT. But we're seeing a couple companies take the initiative and use a flexible gateway so they can go take their high ROI applications in these environments and get the infrastructure installed. But then what they're realizing is now that they've put all of that infrastructure in place, they can upsell and get additional value out of that by bundling applications from other vendors and putting that in those same buildings and same customers. But eventually what we're going to see is that the CIOs at these big companies, these global warehouses, these restaurant chains, these property management companies that have millions or billions of square feet under management, they're looking for strategies where they can, just like they've done with Wi-Fi, build a comprehensive Bluetooth infrastructure strategy that they can deploy throughout their entire buildings and ecosystem. When that happens, as-a-service companies can partner with sensor device vendors to start deploying edge apps, just like we see consumer devices, where companies can just deploy an app onto the cell phone they already have in their pocket. BLE is not just going to be in these retail stores, it's also going to be in warehouses and restaurants and in hospitals too. If we think about hospitals, those places have patient data, you're trying to track pharmaceuticals and drugs to make sure that all of those are accounted for. Security is really important in all of the commercial IoT applications that we've been looking at. And the good news is, if we keep looking at mesh, as Chuck mentioned earlier today, security isn't optional on Bluetooth mesh. Mesh has a lot of really good features that make security work really well. I think we've heard terms like industrial grade or government grade or military grade. And I don't know which one of those is actually the right one, but I do know that it's FIPS 256 elliptic curve that is used for the key exchange. And I know that there's a key refresh that enables these devices to not get stale when they're out there in those environments. And the Bluetooth mesh also accounts for things like devices that need to go through an entire life cycle where they're being recycled or taken down because maybe they've failed in some way. And so there's a mechanism for blacklisting and keeping those devices from getting P refreshes, which essentially means you can throw a device away without worrying about it being a vector for an attack back into your network. And all of that's at the network layer. That's the transport of these different Bluetooth mesh devices. But if we look instead at the applications that run on top of it, you can imagine in a hospital that you don't want your patient care monitor data to be visible to the wheelchair cart or the wheelchair tracking application. So we have many different application keys that actually enable us to segregate the data going through the mesh in different ways. If we took a look at where that application data is going, it's going from that mesh into these gateways that are installed in all these commercial office buildings. Just like we have app keys that make it so that different devices on the network can't see the application data from each other, the infrastructure itself that's providing these applications is going to use containers to separate these different applications from each other. We don't want a text messaging app on our cell phone to be able to look at our bank account information from our banking app. So why should we expect, or we should expect the same level of separation inside the edge infrastructure that is going in these commercial buildings. These containers also allow us to separate the edge application from the OS or all the other features that make up this infrastructure. This infrastructure is going to be installed and maintained, and it's going to be in physical places. So it's going to be on the ceiling in this building, or might be in a closet, or might be on the wall somewhere. And when those devices are in those physical environments, we have to take extra care for security of the device itself. And that means that on the edge infrastructure, we should demand things like encryption for all of the storage that's there. Make sure that if you have an application key or a token for accessing your cloud infrastructure, that nobody can rip that device off the wall, take out the flash storage, read it on a computer, and then be able to get access to your cloud. And the other thing that we should do is make sure that, or we're learning that software signatures help make sure that authentic software is actually being written on these devices, or executed on these devices, and it's coming from the authors that should have access to deploy there. So just a couple things that we've learned about edge infrastructure that need to be there for security. We're also learning that a lot of the development teams that are working on these edge applications are focusing almost solely on just making these connections work. They're focusing on a proof of concept or the user experience for these customers, looking at how they package the data and actually provide the ROI, but they're not worried about things like the CVEs, the common vulnerabilities and exposures that happen every day to all the software devices that are out there. So continuous security of this IoT infrastructure requires that, just like those containers we looked at where the application is completely separated from the OS, automatic updates are going to enable that infrastructure to stay secure. And we think about things like Heartbleed, which was I think a few years ago now, that affected OpenSSL. Probably every one of these applications is going to use some form of OpenSSL or TLS to access the remote cloud resources. And so we need to make sure that the infrastructure is continuously updating for things like and correcting those security vulnerabilities. There's been other recent ones like crack, which is a WPA2 vulnerability. It says these devices are often bridging between Bluetooth and wireless networks. Things like that have to be updated. And then Blueborn, which I think was even more recently, is a vulnerability on Bluetooth itself. And since in the previous slide we saw the Bluetooth mesh stack is inside the infrastructure, we should expect the infrastructure is going to be automatically updating and keeping those things continuously secured. But security doesn't stop with just always updating the devices. Security also means monitoring them to make sure that there aren't problems or new threats as it goes along. What I've got on the right here is a picture from August 1st when we were testing some of our devices in the lab, and we see a steep rise in processor. What we found out is that our IT department was actually running an active vulnerability scan in our network at the time that this happened. So we were able to detect that gateways were effectively under attack by monitoring the performance of and the health of the device in real time. So if we take these lessons about connectivity, edge computing, and security, and put them together to see what this has shaped for our vision for commercial IoT, we know that we have to connect the devices, and we're going to do that with Bluetooth mesh, but we're also going to see support for connectivity and advertisements. There's going to be models for building standardized devices in these commercial environments like occupancy sensors, so that as a service, companies can depend on those standard models to build applications. We know there's going to be edge computing so that BLE can be translated into cloud. We know that all of those edge applications are going to run in secure environment, isolated from each other. We know that everything is going to be sent to the cloud in a secure manner with things like up-to-date TLS libraries. And importantly, we know that security is going to be built on updates, performance monitoring, the ability to rapidly roll out a bug fix or a new feature. But the most important thing that we've learned as we've looked at all of the commercial IoT is that shared infrastructure, the ability to run lots of different applications on a single set of devices in these buildings, is going to be the one thing, that most important thing that enables commercial buildings to become BLE enabled. So we'll see edge computing, device connectivity, and scalability and security so that the ecosystem can provide platform integrations to serverless and other public clouds. As service companies can build their applications, and we can see managed services pop up that can support all the different use cases in